Welcome back to the channel, everybody. So after the last video where we were talking about knock control and setting things up, a couple of questions came up. One was concerning what the smoothing integrator does, and do you need to run the primary frequency? At what point do you switch to the secondary frequency? So because of that, I had a car that I could continue to do testing with AEM based knock control, and most of this will still apply to other ECUs, whether you're using a Haltech or you're using Motec. Anything that has knock control. I don't believe FuelTech has any native knock control, but for the most part, this will apply to a lot of different platforms. So what we're going to do is we're going to get right to it, and we're going to look at the first pull in the dyno graph. This was a 2-liter stock appearing turbo. Obviously it's making really good power, had cams, did 389, 296, just over 18 pounds. And we can see air fuel's dialed, it's ready to go. So, good starting point to help establish what the knock is doing. Now, here is the knock threshold that I had set up, 0.18 in this case. And I'm not really sure what AEM is doing with that number, if it's 18% of 5 volts or it's some other threshold. But at any rate, we can see right here at this 6,848 RPM, we have a pretty big spike on cylinder 4. There's not as big, but still a big spike on number 1. It's pulled 3.1 degrees of timing from number 4. It's pulled half a degree from number 1. We see 1 and 4 there. So when we look at how it was set up, the knock control noise filter settings, in this case, integrator smoothing time, 260 USEC. We can see that it's using a primary frequency for an 85.5 millimeter bore, 86 millimeter bore, the 6600 hertz. Pretty common. This is going to be a 2J, this is going to be a 4B11, more or less a 4G63. You can use this for quite a few things. So gives us a good idea. The rest of the setup, just to show, it's set up the same way. We started at 5 degrees before top dead center for a 40 degree window. So this is the filtering that we were getting. Now we're going to show the dyno graph after changing, and then we'll go back to Infinity and look at what I changed. You can see that for the most part it's pretty much identical. It made 1 more horsepower, made a little less torque. Right here in the 5,800 RPM range, it was down 8 foot-pounds or so, 8 horse. Just variation from run to run. The timing was the same. Realistically, everything was the same. And I have spent the time to go through it and look. Now, if we switch to that file, which was run 3, we're going to see noise fairly reduced. Ran a little bit more timing there. 6,800 though, we're going to go back to that. Zoom in here. Still the same 7 degrees, no timing pull. And what I changed was the smoothing time. Went from 260 to 360. So what that does is it's the time that has to transpire before it looks for another knock event. Now, we'll get into whether or not that was a real knock event. That's not necessarily what I'm trying to show here. Obviously, if the power didn't change and it pulled timing, then it was probably too much on number 4, or it pulled it so fast on number 4 that it didn't affect overall power. So I've zoomed in to show some spikes that still exist even after moving the smoothing integrator. So we see here's one at 6,400. There's a couple a little further up at 68. In this particular one, I don't think we can see it. We'd have to go back to number 2, but 6,800 had some events. And basically, it really only has the one here, which I believe is 7250. So now we're going to start changing the values around a little bit more, and we're going to move to the next run and see how that has evolved. Since I was feeling comfortable with the combo overall, and I knew the timing was low, at least based on a stock ECU number, I went ahead and added a little bit of boost. We can see the power has come up. Now it's 420 horsepower, 305 foot-pounds, just under 20 pounds of boost. And when we look, it's pretty smooth. There's a little dip here at 7,000. We'll see what happened there, but makes peak power basically where I chopped at 7,892 RPM, so 7,900 more or less. And when we switch back to the software, there's a spike at 6,400. That's come back. And the reason is because I started moving that smoothing integrator down. I wanted it to start working a little bit faster. So at this point, we ended up at 300 USEC. We have the one highlighted event. We have one up here at 7,500 or 7,800, right near the rev limiter, but that's normal. We have one here at 7,500. But for the most part, really smooth. Again, it pulled the timing in and out so fast that if it was a true knock event, it covered you, because this one pulled 2/10, so really not much. Then when we look at this one, number four was pretty rowdy, so it ended up pulling 2 degrees of timing out. So I skipped ahead in the process of tuning this car. We're up to run 9, but as you can see now, all of a sudden there's a bunch of noise on number 4. It's pulling 4 degrees. We have a bunch of spikes, 6,800, 7,000, 7,100. All of a sudden things are just starting to really misbehave. And at this point, because number 1 and number 4 were being a little bit more noisy, as we term it, here you can see it's 0.295, 0.189. I had gone under ignition trims, and I was pulling timing out of those cylinders to start with. Now, when we look at the dyno sheet, it is the red line. It pulled timing on top of timing, so right here in that 6,800 to 7,000 range, we end up losing about 25 horsepower. It's definitely not smooth. It's very noisy. And I knew something was going on. I knew this was the spark plugs. So for the sake of discussion, I had put the cylinder trim back to how it would normally be, which when we switch, it's going to be zeroed out. It's going to be individual timing. Now, the other thing of note here, and this is an example of why you need to be careful doing this, is we had doubled the frequency at this point, because I was trying to determine, I already knew what the problem was. We're going to get to that. It was spark plugs. But I went ahead and doubled the knock frequency. And as you can see, it basically just chopped this in half. It went from the 0.28, 0.29 to 0.149. The spikes still exist, but it didn't pull any timing, so it picked up that power. That's normally how I determine if something's phantom knock. I don't have deck cans. I don't have the best hearing anyway, and I don't feel that you can necessarily pinpoint a deck can noise in a data log in one ECU. You have to have some really good software integration, which I'm not going to fib, I don't. Somebody like Andre Simon might. I know he prefers deck cans. He has it figured out and has done so over time. I just use the knock sensor. Whether it's the Bosch wideband knock sensor, flat response, whatever you want to call it, the one that's in Subaru and Nissan, BMW, etc., or a factory one for like a Toyota 2JZ or a 4G63. I just use that because I have enough experience operating a dyno daily to see what's going on. This particular case, I knew that something else was going on. I pulled the plugs, and they had 29 thousandths worth of gap. So whether it slipped through our pre-dyno process or the customer had changed them in between appointments really doesn't matter. But that was what was causing the problem. Now, when we look, just to show you that I had, oh, whoops, I already had it open. I had doubled this. I had gone back to 360 USAC. So it was becoming apparent to me that this noise was not actually knock. Could it end up in engine damage? Yes. That's why I was keeping the boost low. I was keeping it fairly non-aggressive. Timing at 6400 is 5 degrees. For reference, this is normally 9, maybe 10. So it was definitely low timing. Now, when we fast forward, we're going to go to run 12. We're going to look at actually the highest power that this particular car made. Zoom in here. We have one little bit of noise right here at 7,000, but realistically, it's right under the threshold. I wasn't too worried about it. We can see that we're still low timing, 6 degrees. We had one up here, almost to red line. That can be valve train. I've found with a 4G63 in particular, anything past 7,000 RPM is kind of hit or miss as far as whether the knock control works. When we go back and look at the settings, you're going to see that at this point, I returned it to the primary frequency. I brought the integrator smoothing time down to 320, which is where I was going to leave this one. There's a little bit of unknown about this particular car, whether it was built, it's a factory replacement motor. But at any rate, we can kind of see what's going on. Now, when we go to the dynograph for that pull, we're going to close these and we're going to go to 12. I did make other pulls, but this was peak power. I did a heat-soaked pull, and then I did one just for a dyno video, but we're not going to look at those logs. Here we are, 442. You can see the power's nice and smooth. Timing's low. Indicated air fuel from the dyno is 1197. If we go back and look here, we'll go to the tuning tab. Target was an 11.6. It was recording an 11.7 right there. Bring it up here, still about the same, 11.6. So it was matching targets. Dyno widebands tend to read a little bit leaner generally. We can see the feedback was good. Alternator's doing its job. 8.4 degrees out the top. Intercooler was doing its job. It's 60 degrees. So all in all, this car is done, and I feel that the knock control is safely set up so that whoever drives this car can hopefully do so without worrying about what's going on in the background. They accidentally put the wrong grade of fuel in, or they go to a mom and pop gas station that has junk fuel that almost never rotates out of the tank. They probably don't have to worry. The standalone should be able to catch it. Is it perfect? Is it stock? Definitely not. But it really does improve upon nothing, which some standalones will have, some tuners will do, not set it up at all, or take the time. Possibly they don't own the dyno, so they can't. But in this particular instance, we could see here that where it did exceed cylinder 3 all of a sudden, 7600, it pulls a little bit of timing. We didn't really see it in the power graph, so that could be a little bit of heat soak. I mean, realistically, 60 degrees isn't hot, but that's the temp of the air moving through. That's not necessarily heat of the piston, of the cylinder head, etc. We could have glow-in-the-dark carbon inside and not really truly be able to see that. Anyway, guys, I hope this helps answer some of the questions about how AEM's knock control works specifically. If I have time, I will dedicate a little bit more to the Hall Tech. I'm going to include a picture right now showing what the knock trace looks like so that you can kind of see what it does. It's 6,700 hertz. It shows to 13,400. It allows you to do a spectrogram, so you can try to induce knock and get a good idea of what it looks like for that ECU. The version 2.45 and above, I think now they switched to the NSP software, so it's version 3. It all works very, very good. I've been using it on RBs, and I'm very impressed. I never really thought that Nissan knock sensors worked very good, but integrated with a Haltech, you definitely see a lot more things going on than you would with other ECUs. So if this is content that you like, please consider subscribing if you haven't. Hit the thumb button to show me that you like it. If it's something you know someone else will like, please consider sharing it with them. And if you want notified of new content as it's added, hit the bell icon and YouTube will do that automatically. Thanks again, guys. We'll talk to you later. Bye.